Let's learn the concepts of linear and exponential growth from the beginning with some solved examples. So what is linear? Linear means that the same amount is added or subtracted at each time step. So it basically works on the principle of a constant difference. So there is a constant difference. Now, if we look at the graph, so for the black graph, we can see that while x is increasing, y is also increasing. So basically this is a straight line and this denotes a linear growth. And similarly, for the red line, we can see that while x is increasing, y is decreasing. So this basically shows a linear decay. Now let's look at an example. I add 10 new books in the library every year. Now, if we see at the problem, it states that it is increasing by a constant amount which is getting added. So basically, this is an example of linear growth. Now, if we look at the exponential growth or decay. So here, the same amount gets multiplied or divided at each time step. So basically this works on the concept of a constant ratio. So if we look at the graph over here, we see that the black graph shows that while x is increasing, y is increasing, but it is increasing in the form of a curved line. This is not a straight line. So basically this denotes an exponential growth. And similarly, for the red line, while x is increasing, y is decreasing in the curved manner. So that is an exponential decay. Now we have an example that I have $10 and it is increasing by 10% every year. Now we know that this is expressed in the form of a percentage and it is compounding by 10%. So basically we have to multiply 1.1 to the amount of the previous year, right? So this is basically getting multiplied by a constant amount. So it is getting multiplied by a constant. So that makes it an example of exponential growth. So now we can just summarize the differences of linear and exponential. So the first thing that we notice is linear is a straight line which works on the equation y equal to ax plus b. And for the exponential, it's a curve and the equation is y equal to ab to the power x. The second thing is the linear is a constant amount that is added or subtracted. And for the exponential, it's basically a constant ratio. So the same amount is multiplied or divided. Now we can solve some questions so that we understand the concept a bit better. So simple interest and compound interest are examples of. So for simple interest, we have the formula that it is the principal amount into the rate into the time by 100. And this is constant for every time period, right? This gets added. This amount gets added. So this is basically a linear growth. And similarly, for the compound interest, we have p into 1 plus r by 100 whole to the power t. So this portion gets multiplied every year. So this or every year or every time period. So this is basically a ratio and this is a constant. So basically this is an example of exponential growth. So simple interest is linear growth and compound interest is exponential growth. Okay. The next thing is a library has 800 books and adds 500 every year. So we are starting with 800, then we add 500, so it becomes 1300. Then in the next year we add again 500, it becomes 1800. then it becomes 2300, then 2800, and so on. So we see that it is getting added by 500 every year, right? This is getting added by plus 500. So this is a constant amount which is getting added. So this is therefore a linear growth. Okay. The next is a bank account starts with $100 and every month the amount gets doubled. So what type of growth it is? So we have 100, then it becomes 200, then it becomes 400, then it becomes 800, and so on. So it is getting multiplied by 2, right? So we have a constant and it is multiplied. So therefore it is an example of exponential growth. Okay. Now the fourth question is y equal to half x plus 8, and what type of relationship does this exhibit? So just looking at it, we can say that it is linear. Why is that? Because it is of the form y equal to ax plus b, and this is a straight line equation. So that is always linear. Now we can just, for our checking purpose, we can put some values and check it as well. So x and y, when x is 0, y is 8. When x is 1, half into 1 plus 8, so that is 8.5. Similarly, when it is 2, it is 9. When it is 3, it is 9.5, and so on. So we can see it's getting added by plus 0.5. So this is getting added by a constant. So we can say for sure that it is linear. And the last question is y equal to 8 into half to the power x. Just by looking, we can say that this is exponential. And why is that? Because it is of the curve y equal to ab to the power x. So similarly as in the previous question, we can put some values and check. So if we put x equal to 0, then it is 8 into half to the power 0, so that is 1, so 8. Then we put 1, so that is 8 into half, so that is 4. Then we put 2, that is 8 into half, that is 2. Then we put 3, that is 8 into half, so that is 1. So if we look at this, it is basically getting divided by 2 at each time step. So this is an exponential, but it is a exponential decay because it is getting divided by a constant amount.